Okay. This chapter, if you guys have done any statistics in the past, it's probably going to show up in this chapter. So like now we're going to do mean, median, mode. We're going to do frequency tables today. We're going to talk a little bit about histograms. We're going to eventually do box and whisker plots. So a lot of things that you guys have seen in the past are going to show up in this chapter. We'll go maybe a little beyond what you've done with it before, but a lot of it's going to be familiar. And then when we get to chapter 3, we'll start seeing some of the new stuff. All right, so today is mostly frequency distributions and their graphs that go along with it, which are going to be histograms. So a lot of like little definitions on this page that you need to write down first. Let me make this a little bit bigger for you. Okay, so frequency distribution has several parts. The first part are what we call the classes. The classes are either a category, so it could be like animals, dogs, cats, fish, whatever, or it could be groups of numbers like you see here. Most of the time when we create one, it's going to be groups of numbers. It is important that the class width, the size of each class, is the same. When we say class width, we're talking about how many data values are within that class. So one way to figure it out is you can just count it on your fingers, like 11 to 15, 11, 12, 13, 14, 15. The class width is 5. Or a way you can calculate it is you can take the start of each class, which is called the lower limit, and subtract them. Or you can do the same thing with the upper limit and subtract them. What we don't want to do is subtract the first and the last number in a class. That will only give us 4, and we know that there's 5 numbers in that set. So we want to, if we're going to find the class width, subtract the start or the end of 2 consecutive classes. How many classes we have? We typically use about 5, maybe a little bit more. Any less than that, it probably wouldn't give us great data. That's usually predetermined for us in a problem. The bottom number in each class is called the lower class limit. The top number in each class is called upper class limit. How we figure out what numbers are going to go in our class to create our class width is we're going to, and we'll do this in a minute on your paper, we're going to find the range, which you guys know how to do that. It's maximum minus minimum. So that tells me how wide my data set is. And then we divide it by the number of classes we want. So like here, there's maybe 8 classes. So we take all the numbers we have, figure out the width of it, its range, divide by 8. And then if you get a decimal, we're always going to round up. And that ensures that when we create these classes, we have a spot for all of our numbers. Because when we make a frequency table, then often we don't see the tally marks, but you could if you wanted to. Tally up how many numbers fall in each of these groups. And then the frequency is really what we care about. So when we see a frequency of 2 for that first class, it means in this raw data set, whatever it is, there are 2 numbers that are between 11 and 15. So it might be an 11 and a 12, or it might be a 15 and a 13, or it might be 2 15s. We don't know from this exactly what the data is. We just know how many numbers fall within each class. Okay, so like I said, a few definitions on here. You can paraphrase how you want with those. And then we'll do an example on your paper, your handout that I gave you in a second. And we'll set up some classes and get some frequencies for a data set. Everybody have what they need here? Okay. All right, so to that little handout I gave you, we're just going to do a couple things on this, and then we'll come back to it in a minute after we get a few more definitions. So we've got this data set. This data set lists the out-of-pocket prescription medicine expenses in dollars for 30 U.S. adults in a recent year. We're going to construct a frequency distribution using 6 classes. Okay, so first thing we need to figure out is how big we want to make each class, the class width. So to figure that out, we're going to take our range first, which is the highest value in the set minus the lowest value in the set. And this is not ordered. That's always an extra step you can do if you want to, like when you're doing your homework and stuff, is you could take the data and you could order it from like least to greatest. It might make certain things easier, but sometimes that's tedious if you have a big data set like this, so I'm not going to do it. What's the biggest number in this set that you have? 405 is the biggest. Agree. And what is the smallest? 155. Okay, so my range, I subtract them. You're going to need a calculator. If you don't have one out yet, you might want to grab it. 405 minus 155 gives me 250. Once we have our range, we divide it by the number of classes that we want, which are the number of rows we're going to create. Here we were told we need 6 classes. So divided by 6 gives me 41.6 repeating. Okay. Whatever that number is, we are going to round up to the next integer. If you round down, you're going to get stuck at the end because you're going to have a number smaller than that maximum value and won't be able to fit all your data in the table. So we always round up. There might be extra room at the end. That's okay. But we want to make sure we round up so every data value has place. All right. So I'm going to round up. My class width is 42 for this data set. Okay. So what does that mean? When I start creating my classes, I'm going to start with the smallest number. And I want to ensure that in each class, there are 42 numbers. So the easiest way to do that, I told you the class width can be seen in the lowest class number or class boundary or whatever we want to call it, lower limit for each class. All I have to do is take 155 and add my class width, 42, and I'm going to get where the next one starts at. So 155 plus 42 is going to give me 197. I'm going to fill out the lower limits first. Just keep adding 42 all the way down. 239, 281, 323, and 365. Okay. Wherever one class starts, the other one ended 1 unit before that. So if this guy's going to start at 197, that means this guy ended at 196. So 155 to 196 is my first class. 238, 280, 322, 364, and then if you want to figure out that last number, all you have to do is add 42 to where this one ended. 364 plus 42. 406. And you want to double check that that number is at least where your maximum value is, if not higher. It's a little higher, so I know that all my data is going to fit in this table. Okay, so now the part where we have to be extra careful when we do this. Our F stands for frequency, which means how many data values fall in each of those classes. You can tally if you want to, but ultimately we're looking for like the total number here is all we need in that column. So what I need to do is I need to count how many data values are between 155 and 196. When I do it, I'm crossing them out as I use them. That way I don't forget anybody. Thank you. Okay, so in my first class, between 155 and 196, I've got 155, 165, what else? 195, 168. Are there just 4 of them? Does that look good? Okay, obviously if the data was ordered, this part would be a little bit easier. Okay, between 197 and 238 then. Let's see. 1, 2, this 2. Okay, between 239 and 280. 1, 2, 3, 4, 5, 6, 7. I have 7. Between 281 and 322. 1, 2, 3, 4, 5, 6, 7, 8, 9. Between 323 and 364. I've got 1, 2, 3, 4. Bless you. Right. And that, oh, I missed one. 5. And then last, I'm left with 3 numbers there. 3. If you want to double check at the end here that you've got them all, if you're crossing things out, just make sure you didn't cross somebody out twice or something. Have you guys seen this symbol before, the little summation symbol, sigma? This frequency column should total the number of data values you have, which in this problem was 30, we were told at the beginning. And we're going to use the letter N to represent the number of values in our data set. We're going to see that in a minute. So this frequency column will always total up to be N, whatever that is. So you can double check you've got all your numbers accounted for. Okay, so any questions? Creating classes and getting a frequency from a data set for those classes? No. Okay, next. A few more definitions you need, and then we'll pop back to that table and fill out the rest of the columns. So once you have a frequency table, we can also get midpoints of our classes, relative frequency, and cumulative frequency. Midpoint of our classes is exactly what it sounds like. We're going to take the bottom number, my lower limit, the top number, my upper limit, add them together, divide by 2. It's just like when you calculated a midpoint back in like college algebra, right? Take the bottom number, top number, add them together, divide by 2. It's like an average, essentially. Relative frequency, you've got a little formula for this one. It's F divided by N. F is the frequency of each class, and N is your total sample size. Relative frequency is essentially a percentage of the data that falls in that class. Okay, so if I get a number of 0.2, means 20% of the data is falling in that class, in that row. And then cumulative frequency is the sum of all frequencies for that class and all the previous classes as well. And that will eventually total up to our N, our sample size. Okay, so I'll give you a minute on these. I've got one more on the next slide for you for class boundaries. We'll get that one written down, and then we'll go back to our table and fill out the rest of it. Okay. And last but not least for our frequency table that we need are class boundaries. So class boundaries, you can see here in an example, we've got our classes, our frequency. Our class boundaries allow my classes to start and stop at the same place, which eventually we're going to want that when we make a histogram. You guys remember doing histograms at all before? The bars touch, so we don't want a gap between the values. So pretty much what we do to get a class boundary is we just take our classes and extend them a half a unit in either direction. So you can see here it went from 18 to 25. My class boundaries, if I go a half a unit in either direction, are 17.5 to 25.5. And then that ensures that the upper limit here is the lower limit of the next one. There's not going to be a gap between our classes. So there's not like a great like formal definition of writing that down. You can just write extend the class half a unit in either direction. We're not going to have classes that jump more than a unit from one to the next, so we're always going to do it this way. So it's just going to be a half each time. Class boundaries and midpoints are what we're going to use to label our histograms and graphs when we make them in a little bit here. Okay. All right, so now back to your handout that's got your frequency table on it. Let's go ahead and fill the rest of this out. Okay. So for midpoint, all we have to do is take my lower limit, my upper limit, add them up, divide by 2. We're finding out where is the middle of that class. So you need your calculator for this. 155 plus 196 divided by 2. And you're going to get 175.5 is my midpoint. Okay, same thing for each class, just repeat the process. 197 plus 238 divided by 2, 217.5. 239 plus 280 divided by 2, 259.5. And you're going to notice as you do a couple of these, once you have the first one, it's actually just increasing by 42 each time. It's just going to be our class width is the difference from one to the next. So that's kind of a shortcut. If you don't want to do the midpoint formula over and over again, you could just keep adding 42 to this, and it's going to be the midpoint for the rest of your classes as long as you set your classes up correctly. So if I add 42 to that, I get 301.5. Add 42 to that, 343.5. And add 42 to that, 385.5. Okay. Class boundaries, we're just going to take our classes and we're going to extend them a half unit in either direction. So instead of starting at 155, I'm going to start at 154.5, half a unit down. And instead of ending at 196, I'm going to go half a unit up. 196.5, which is where the next one's going to start. 196.5, 238.5, 238.5, 280.5, 280.5, to 322.5, 322.5, 364.5, 364.5, to 406.5. All right, relative frequency and cumulative frequency. Relative frequency, think of that like our percentage. It's just going to be F divided by N, where F is the frequency of the class and N is our sample size. So in the first one, it's 4 over 30. You can write it as a fraction, but usually we're going to see this as a decimal, which is 0.133. I'll give it 3 decimal places. Okay, so that tells me about 13% of the data is falling in that first class. And then just continue from there. 2 over 30 for the next class is going to be 0.067. 7 over 30, 0.233. 9 over 30 is just 0.3 exactly. I don't have to round. 5 over 30, 0.167. And 3 over 30 is going to give me exactly 0.1. A way to check your relative frequencies. Remember, these represent percent that falls into each class. So what should the total percent at the bottom end up being? Do you suppose? Yeah, the sum at the end should be 100% or just 1. And we rounded, so you might be off by like 1,000th or something. But it should be approximately 1 at the bottom there to represent 100% of our data. Okay. Finally, cumulative frequency. Cumulative frequency is a column that continues to increase. It's going to start with your lowest frequency. Well, I shouldn't say the lowest. Your first frequency in your first class, 4. And then the next one will include the frequency of that class plus anything before it. So the next cumulative frequency I would have is 6. The next one I would have is 13. Then I would have 22. I'm just adding in each class as we go. It gets bigger and bigger each time. 27, 30. The last number in your cumulative frequency should always be N, your sample size. Okay. Any questions? Getting any of this information in a frequency distribution? All the pieces and parts. Yes? Oh, yeah. Sorry, I kind of squeezed it in there. It's a summation symbol, sigma. Yes, both of those are the same. We're going to see it show up in formulas throughout the semester, so it's probably good to have it to start getting used to it. But you don't, like, if I ask you to fill this table out, you don't have to have that drawn. You just have to understand what it means. Yep. Okay. Other questions on any of this stuff? Okay, so once we have a frequency distribution, which we kind of went through all that, we can represent it graphically. So most of the time when we represent a frequency distribution, it's going to be with some sort of histogram. You guys have done histograms before. It's essentially a bar graph, but the bars have to touch. Okay. So here's an example at the bottom of tree heights. It looks like our bars here are labeled with the class boundaries. Okay, where one stops, the next one begins. You can see the numbers are between the two bars there, and we'll make one of these in a second on your paper. And then the height of each of the bars is how many data values lie within that class, within that range of numbers. So between a height of 150 and 200, there are about 30 trees. Okay, that's how I would read that. We are going to be very critical about how we label things. Okay, so we want to make sure we label things equally. Okay, we want to count equal along our axes. We also want to label in words with whatever things represent. Okay, here it happens to be height labeled in centimeter and number of trees. But you want to make sure every axis has a label and it's organized nicely, so we get a nice view of what our data actually looks like. Okay. All right, so on your handout, we're going to take the data that we just did in your table, and we're going to make two different histograms here. The first histogram is labeled with class midpoints. Okay, so what you see on the bottom here, these are the midpoints that we just calculated. I went ahead and labeled them for you already. Couple things to notice. I labeled all your axes, so expense in dollars is what I'm looking at on the bottom. That's what my data represents. And on the side is frequency. When we see frequency, it's just how many is what we're talking about. So we're just labeling 1, 2, 3, 4 all the way up. My x-axis did not start at 0, so I have a little break in the graph to show that there's a jump from my origin to get to whatever this first value is. Because we're labeling with midpoints, these tick marks are going to be in the middle of the bar that we create. And remember, the bars must touch. So that first frequency we had was 4, right, for the first class. So where 175.5 is, I'm just going to draw a bar. Yours is probably going to look better than mine. Up to 4, just make sure 175.5 is right in the center of it. Okay. What was my next frequency? It went from 4 to 2. Is that right? Okay. So my next bar at 217.5, representing my second class, goes to 2. Then it went to 7. Okay. All your bars should be the same width if you've labeled your x-axis correctly. Then it jumped to 9, I think, right? And then to 4. Right? Or no, 5. Was it 5? Yep. And then 3 was the last one. Okay, so there's my histogram. Okay. Another way to create a histogram, another way to label it, is with class boundaries, like the one on the right here. So instead of on my x-axis counting by midpoints, you can see that those class boundaries we created, where one class stopped and the other one ended, is what my numbers are. We can also, instead of frequency, which is counts, use relative frequency, which that essentially represents the percent of the data that falls there. Okay, so here, because I'm labeling with class boundaries, where you see the tick marks, is going to be where your bar starts and stops at. The tick marks now won't be in the middle of the bar, they'll be on either side of the bar. And then instead of going to a height of 4 for the frequency, I'm going to use the relative frequency, which what did we find for the relative frequency for that first class? 0.13. I'm just going to take that bar up to 0.13. Okay, and it starts and stops where I see those labels on the x-axis. Okay, the next one was 0.067. The next one, what was the next one? 0.2 something, 233. Okay, and I know that, I'm not doing that math quick in my head, because what are you guys noticing about the two histograms here so far? Essentially look the same, right? It's the same representation of the data. It's just a different way to label our things, okay? The next one was 0.3 exactly. The next one was 0.16 something. And then the last one was exactly 0.1. Okay. So we can label with midpoints, we can label with boundaries. That just tells us what's happening on our x-axis. Our y-axis can be a frequency, a count, or a relative frequency, a percent. And that's all up to you how you want to make those. Or it'll just be told to you in the instructions. Okay, questions on histograms? Okay, the last two graphs we need to talk about are on the back of your paper, a frequency polygon, and then we'll get to an Ogive graph in a second. So this is on the back of your handout. A frequency polygon is essentially a line graph that shows the change in the data. But what's a little bit different with this from what you guys have done with line graphs before is it is going to begin and end on the horizontal axis. It must start and stop at 0 to ensure we have a polygon. If you remember the definition of polygon from geometry, it is a closed figure. So we don't want these like gaps on the end. We want it to touch the x-axis on both sides. The graph that I've created for you here, which is pretty much how we're going to do our frequency polygons in this class, is it's labeled with the midpoints again that came from our frequency distribution table. But I don't want to start with 175.5 because if I graph a dot for 175.5, that frequency was 4. It's going to be up here. I'm going to graph that eventually, but it has to start on the x-axis. So what we're going to do is we're going to take these midpoints and we're going to go a whole class back and a whole class forward to ensure that we're at a value before my data started and a value after my data ended. Remember, our class width was 42 for this problem. So I'm just going to take 175.5, my lowest midpoint, and I'm going to subtract 42. And then I'm going to take 385.5, and I'm going to add 42. And that's going to give me a number before and after my data ended, so it ensures I'm going to be at a 0. All right, so 175.5 minus 42 gives me 133.5. You can fill in that one. And then if I do 385.5 plus 42, I get 327.5. Okay, so if I'm at 133.5, nothing has happened yet. I have no data values in that class, which is good. We got to start at 0. Now I can do at 175.5, I was at 4. At 217.5, I was at 2. That one was 2. The next one, we went up to 7, then 9, then 5. The last one was 3. And then after that, if I went one class beyond it, I would be back at 0. Connect your dots. We create a closed shape with that x-axis, and we have a frequency polygon. Questions on frequency polygons? Okay, you can always shade that in too if you want to. Sometimes you'll see that happen. All right, last but not least, is what we call an Ogive graph. An Ogive graph is a graph of cumulative distribution. So our cumulative frequencies are graphed when we have an Ogive graph. Because it's a cumulative frequency, something that's going up, you will see a line graph that is constantly increasing. It's just going to change its slope based on how much it changes from one class to the next. Notice this one also starts on the x-axis. So we start at 0, and then we increase from there. So an Ogive graph, sometimes called a cumulative frequency graph, shows data values and its cumulative frequencies. It could be relative frequency also for this one. So we're going to do one of these on your handout, and then that'll wrap it up for the day for us. That'll be all the graphs we need for this section. Good? Okay. So last one on your handout. This is data that's similar to the one we had. It's just the numbers are slightly different. I wanted a different graph here. So I went ahead and made classes already. I counted up frequencies from a data set. All we need to do is fill out the cumulative frequency for each of these to start. So cumulative frequency, or the frequency we have, starting with 5, and then all the ones before it. So if my next class is a frequency of 3, 5 and 3 gives me 8. Keep going from there. 14, 23, 28, and 30. Okay. Graphing this, you can label it with boundaries if you want. Let's go ahead and do that. I think that's the easiest way to do this. You can do midpoints too. I like the boundaries though. Okay. So boundaries, my first class started at 155, so we're going to go a half a unit back. 154.5 is going to be my first tick mark. And then I'm just going to choose the middle of where one class stops and the next one starts. So the next one, or that first one ends at 200. The next one starts at 201. So the middle of those are a half a unit in either direction is 200.5. 246.5, 292.5, 338.5, 384.5, and 430.5. Here we're graphing frequency, which is just our numbers, not a relative frequency, a percentage. I have to get up to 30. So I'm just going to count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And it's going to be a line graph. Again, starting at 0. I know that first one starts at 0 because my first data value doesn't begin until 155. So if I'm at 154.5, I haven't had any data values yet. I'm sure they start on my x-axis. Then when I'm at 200.5, that means everything in the first class is accounted for. So I'm going to make a point at 5. These are just each of those cumulative frequencies. When I'm at the second tick mark, it means the first and the second classes have been accounted for. So now I'm at 8. So on and so forth. 14, 23, 28, and the final one is 30. Again, it's just a line. And your final point will be your N, your total number of data values in that set, which here is, looks like 30. Yeah. Okay, and that's an Ogive graph, a cumulative frequency graph. All right, that is it for section 2.1. Your 2.1 Math Excel is due on the 28th. This would be Friday night. You probably want to get started on it, maybe do a little bit today. It's not difficult stuff like you guys can see, but it's a little tedious, like organizing the data and getting it sorted and stuff, so it could take a few minutes to do that, unfortunately. Okay, tomorrow I have like a little exit ticket, like just a little practice of this kind of stuff, so we'll kind of recap, and then we'll do section 2 tomorrow, and we'll graph some things. Yes?
Can you go back a little bit?
Absolutely. To what?
If you go to the cumulative frequency graph,
This one?
yeah, and then what are cumulative relative?
So, cumulative frequency are just our numbers, our totals.
Yeah.
Relative frequency would be if we labeled it with like the percentages. So.
What is a cumulative relative? It says it has both of those.
So if I had, it could be either. It just depends on how your y-axis is labeled. If it was a cumulative relative frequency, my top number would be 1 because it represents 100% of the data. And it could be labeled with like 0.1, 0.2, 0.3, and you're just totaling up that relative frequency column. So like in the first class, you might only have 0% of the data. And then once you include the second class, you have 5% of the data, and it eventually goes up to 100% if it's labeled with relative. Does that make sense?
Yeah. And
okay.
Then, could you also go back to, not the last graph, but I think it, yeah, that one.
Did you have a question on that one too, or just need to see it?
I just need to get a chance.
Okay. For future reference to you guys, I don't know if I mentioned this before. I do record this, all of it. I'll record either you guys or first period every day, and then these solutions are posted online too on Polaris after fourth period. I'll make sure I post them every day for you. So if you're ever absent or you missed something and you want to go back to it, it's all going to be in Polaris for you. Yes. Absolutely. Any other questions? Any of that stuff? Oh, okay. Salvo and Lotto. Maybe 3.
Let's go.
Is that you? Okay. You may get your phones. The last few minutes are yours. Here, sir.